to my YouTube channel. Homework help, lesson 3.3. Let's get it, guys. Yeah.
All right, good job, Abby. All right. Oh, you know what? It's still frozen. Okay, I have it on the first question
That's
already.
funny.
So here we go. Everybody has it open right on their Chromebook. This is what we're working on, lesson 3.3. We're going to go through everything. Your questions are exactly the same as my questions. The only thing that might be different is instead of a 2, it might say a 3. Instead of a -5, it might say a -6. Because they design it in a way so that you guys can't really cheat off each other and just be like, hey, what are all your answers for the homework? You actually have to do it, but the process is exactly the same. So let's work through it. Is this big enough? Can you see it? Why is it? It's always so tiny. Yeah?
Mine's different.
You
said it would be different numbers. Yeah. But you said.
So the question should say graph function of f of x equals, and then it'll say some sort of function. It could be different numbers.
You mean given?
I said graph.
Got answer.
Can't even read a word correctly.
Give it, Hallie.
This is why I need more dollar enters, because I keep making so many mistakes.
Steal it.
Callie, give her the dollar enter. My God. It's like a matrix move right there. Back up here, please. Back up here. Okay. Given f of x equals 5x plus 3. Does yours say 5x plus 3?
Wait, let me check. No.
That's okay.
You don't get to know.
That's okay.
Yes, I am. Give me a second.
It's just a function. So my machine, my function, girls, my machine is saying that whatever you put in, the input, whatever you put in, the machine is going to multiply times 5, and then it's going to add 3, right? Your machine might say when you put something in, it's going to multiply it times 2 and then add 6. It's just a different machine, but it's a function, okay? Now, g of x says that 5x plus 3, or my original function here, is then going to be, 5 is going to be taken away from it. So, is 5 being taken away from the input or the output? Very good. If it were being taken away from the input, it would be 5x minus 5 plus 3. Remember, if it were being taken away from the input, it would be showing it just being subtracted from the x. But since 5 is being subtracted from the whole function, the whole machine, and this equals the output, this is being taken away from the output. Okay. So, when you're subtracting from the output, and I have my little cheat sheets up here if you ever want to look. Okay.
I don't think they can see that.
That's okay, I'm just going to read it. Where's my, okay, subtracting from the input, adding to the output. Okay, so adding or subtracting to the output moves the graph vertically by that many units. So, for this one, subtracting from the output is really just changing the y-intercept, right? It's really just saying, well, this is 5x plus 3 minus 5. So it's taking your y-intercept of 3 and moving it down 5 units, right? So if the y-intercept is positive 3 over here, I don't know if they can see that, it's moving it down 1, 2, 3, 4, 5 units. So how can we describe that? We are subtracting it from the output, which changes the y-intercept. So how does the graph of G compare with the graph of H? It says the graph shifts 5 units up. What did I say?
H.
F. I'm going to let that one slide. The graph shifts 5 units up? No, because it's going down. The graph becomes less steep? No, that's with stretches and compressions, which we haven't learned yet. The graph becomes steeper? No. The graph shifts 5 units to the right. No. The graph shifts 5 units down. Yes. So your answer choice, your correct answer choice might not be choice E, but if you are subtracting from the output, it is changing the y-intercept and moving it downward that many units. Are we good? Are you guys able to apply that to what you're working on? So give me an example. Somebody tell me what the g of x is doing at the end. Subtracting.
Oh, wait, so it's subtracting, so that's why it's going down.
Yes.
Oh,
And
okay.
that's the rule. This is where it gets a little confusing. That's the rule when you're subtracting from the output. If you're subtracting from the input, it's a little bit different. We'll go through that in another question.
So
Okay?
like minus plus 7, so that
Plus
means
7.
it'd be going, the graph shifts 7 units up.
Yes.
Okay. And then that's
Because it's being added to the output.
Okay, that one wasn't too bad. You were explaining it, and I just started to think about everything.
Okay, let's see what's happening here. So do you think this is a similar question or is it totally different?
A similar.
Yeah. Because we have function of x is 3x plus 7, and then we have g of x is 3x plus 7, but 13 is being added to this whole thing, which means it's being added to the output. And when it's adding to the output, it's changing the y-intercept, because you really are doing 7, which is the original y-intercept, plus 13. So it's going from 7, which would be 1, 2, 3, 4, 5, 6, 7. When you add 13, it's shifting what? Up how many?
13.
Good. The graph shifts 13 units up. So that would be my answer. Does anybody have one that they want to talk about? Whether it's like -2 or like plus 50? Anybody have a question that they want to throw up here because they're like, well, I don't know what to do about mine? Or are we all good? We're all good? Okay, that was number 2.
Oh, this one?
Oh, I did not mean to put this one on here.
Which one? Which one? Do you want to see my answer?
I did.
Yes.
So
We're gonna skip.
I did that.
What did you put?
I'm on question 6. I put the graph.
No, this one's okay. This one's okay. We can do this. We can do this.
I think you meant to not put questions.
Really? Okay, we'll take a look. Okay, so this is okay. Let's see what happens. The first thing we're gonna do is notice that this is 4x plus 5, and this is 4 times x plus 11. So let's go ahead and distribute this. So now we have 4x plus what?
5. Oh, sorry, 11. No, 44.
Plus 44.
Sorry.
Okay, so this one's 4x plus 5. This one's 4x plus 44. And then 5 is being added to it.
Oh, and then we. No.
Oh, no. I'm so sorry. Now I'm confusing myself.
This one's weird.
This one is weird. I see what's happening. Duh. This is 4x plus 5, and this is 4x plus 5. But what's happening to the input?
Oh, it's just adding.
Yes. So we notice here that the input is changing, just the input. Not the whole function, just the input. Sorry, you don't have to distribute or make this more complicated. This situation, we're just adding 11 to the input. So, totally different than adding or subtracting to the output. adding or subtracting to the output, I'm just gonna do a little thing here since we can't look this thing. The output is a vertical shift up or down. If you're adding or subtracting to the output, you're going up or down however many units. If you are adding or subtracting from your input, which is where it's just adding or subtracting from x, you have those parentheses, just the x is changing. It's going from left to right, but the sign goes the opposite way.
Yeah.
Because usually plus 11 makes you think you should go to the right 11. But if it's adding, you actually have to shift it to the left 11. So adding will make it go to the left, and subtracting will make it go to the right. Does this visual kind of help a little bit? Okay. So left and right, subtracting makes it go to the left, that many units. Yes, go. Can you walk around them?
Then it would turn into the graph shifts left 11 units.
That's it. The graph shifts left 11 units. Does anybody have one that they want to throw up here because they have something different?
Number 6.
No, anything from this. Are you guys good? Can you apply it to yours? Okay. So the graph shifts 11 units to the left.
It has 6 parts, though.
6 parts. I don't want to do
Number
6 right.
7.
No, just Miss White.
Yeah.
Number 7 and number 8 are like the exact same format.
Okay.
And by the way, whenever you're done with it and you got one wrong, it lets you redo it while you're done.
Even after you submit it? Great.
Because I'm only doing that one question.
Great. I should probably change my Post-its to make it look more like a visual. Given this function,
Oh, is this number 7 one?
wait, yeah, but this is, no, this is the one that I definitely don't want to do. Because this is the one that becomes, you got this one?
Yeah,
Okay, well, I didn't teach this yet though. How did you do it?
because I saw what the worksheet was, and I just did it.
You saw where,
Like, I only had 2 choices left between all the other answers. So
Okay.
I just saw that it was a positive.
okay, well, let's take a look. I'm trying to think if this is one that I want to just get. How does the graph of G compare with the graph of F?
Yeah,
See, the output is being multiplied by a number. So,
it's becoming more steeper because it's
yeah.
going up.
How do you know that? I didn't even teach that example yet.
If you look at the answer choices, it kind of helps you.
Yeah.
You look
Okay.
at them because it wouldn't be going left.
So
because
it's not shifting, it's not going left or down, so it's either becoming steeper or less steep.
Yeah,
Right.
And then if it's multiplying, it's going up, so it'd be more steeper.
then
But if
one-
you're dividing, they would
The
go
only
down.
thing is there's a difference between multiplying the input and the output. So with the output, I'm trying to remember. Here, let me get out my lesson, because this one's really hard. I can't remember the rules for this one.
I know what it is.
You do.
Because I
Okay.
just have this one.
If you are multiplying the output, okay, so this is multiplying the output. If you're multiplying by a number that's greater than 1, then it makes it a vertical stretch, which makes it steeper. So that is true. But I'm really impressed with you guys because I didn't even teach that example yet. This example is really, really hard. If your output, which is this whole thing, right,
Yeah.
is being multiplied by a number that's greater than 1, if your number, if your constant is greater than 1, then it makes it steeper. Okay. I hope that's.
Oh, so if the number is over 1,
If the number is over 1,
it's gonna.
it makes it steeper.
But if it's
If the
under
number's in between 0 and 1, like a fraction, it makes it less steep, and it's called a
What
compression.
about a negative number?
Wouldn't negative
Uh,
make it less steeper than it is?
Yeah.
Negative, we are not working with negatives yet.
So we're
Not-
going to.
I don't know.
Let's hope not.
But then the crazy part is the other thing, and I haven't taught you guys this yet, but the other thing is if you're just multiplying the input, just the x times something, then the rules are completely reversed. Then it's like if the number's greater than 1, then it's a compression, it gets less steep, but if the number's smaller than 1, between 0 and 1, then it gets stretched and it's steeper. It's really weird and hard to memorize. I'm just glad it's correct. Well, I'm glad I'm recording this, so if anybody has trouble on this, we're doing it together. Okay, oh, so this is another one.
Yeah.
Same exact thing. We're multiplying by a number, we're multiplying the output by a number that is greater than 1. So it's going to be steeper again. Does everybody have a similar question
No. Well, yeah.
on number 5? So the answer is the same.
Yeah.
Oh, I need help on this one.
Number
On number
6. Can I?
This one?
Yeah.
Can you grab me my numbers?
Let me do this one first and we can do yours. Yeah.
When I did this, I read all the answer choices first and then see which one would like fit best.
Okay,
And
that's
I
okay,
just-
that's a
I
strategy.
just ended up using whichever one I did use, which got it right.
Okay, let me read the question first, then we'll go through the answer choices. Given f of x is 3x minus 7, then we have g of x is 3x minus 7 minus 3. So is 3 being subtracted from the input or the output? It's output. So 3 is being subtracted from the entire output, which simply changes the y-intercept. The y-intercept is negative 7. If you take away 3, it's going to be negative 10, right? So it's going to go down by 3. Describe how the value of k, which is our constant, our negative 3, affects the slope.
Wait, it's not negative.
Yes, it's minus 3.
Oh,
So,
I
so
thought you were talking about the 3 in the parentheses.
Oh, no. This is k, that's the constant. How does it affect the slope and the y-intercept compared to the graph? Let me ask you a question. Does it affect the slope?
No.
No, it only affects
The Y.
the y-intercept. So, the slope is unchanged, so far so good, and the y-intercept is shifted down by 3 units. Does that sound like the right answer? Woohoo! We got it on the first try.
Is unchanged.
Yeah?
I did a correction for a question on the email.
Okay.
Oh, where'd you put it? Or did you put the output?
It's changed by the number outside the parentheses.
Okay.
Yeah. The slope is unchanged and the y-intercept is shifted down by 3 units. Do you have the same numbers as me?
No, I put it in the right number.
Thank you, Callie. It's not what?
Callie, if I'm ever out, you're teaching this class, okay?
Miss Light, can you do mine? Can you?
Oh, the one from before?
Number 6, yeah.
Yeah, I can do that. All right. I'll write it up here. Go ahead and tell me.
What? Yeah, but she didn't.
So go ahead and tell me what functions yours says. What was your first function?
So my f of x.
Uh-huh.
Yeah. And then 2x plus 4.
Okay.
And then g of x is this is in parentheses 2x plus 4. And then outside of that is negative 7.
-7?
Yeah.
Okay, so totally same thing. 7 is being subtracted from the output. Remember, this whole thing equals the output. So if this is the output, 7 is being subtracted from the output. All that does is change the y-intercept.
Which makes it go down by.
So the slope stays 2x, but then your -4 is going to change by going down 7. okay? So here, the y-intercept is positive 4. 1, 2, 3, 4, okay?
Yeah.
But then when you subtract 7, it's going to go down 7. 1, 2, 3, 4, 5, 6, 7.
Yeah, so my answer is the slope is unchanged and the
So it's unchanged and it goes down 7.
Yeah.
Just don't get confused by trying to say what the new y-intercept would be, because the y-intercept would be -3. But what the way it's changing is it's actually going down 7, which is just kind of what it says right there. All right, so we only have 2 questions left, but they have lots of parts, but it's okay. This is actually going to be totally fine. I was already
Oh
working
my
on.
gosh, we have the same numbers.
Oh my gosh, really? Does everybody have the same numbers?
Yeah.
Okay, good. Then nobody
I
has.
accidentally got the one thing wrong, so I was trying to go through it again, so I could just restart.
Okay. Oh, I can click on this graph to view the graph of f of x. Oh, I love it. I didn't even know you could do that when I was working on something. When I was working on this with another student. Okay.
This thing has like 6 parts.
Yeah, it's okay. We'll get through it.
It does have 6
Key features
Oh.
of this function are shown. The key features are just, here's a feature. It's the domain, the range, the slope, the y-intercept, and the x-intercept. It's giving you all this information about the features, what this function has. They're shown in the table. For the following transformation, write the function rule and compare the key features of the function g to the key features of the function f. So let's look at the rule. The graph of g is the graph of x translated up 3 units. So how do I write g of x then? What would it look like if it's going to be translated vertically up 3 units? What would that look like?
And the y, the slope and d stuff.
Well, tell me how I would start writing. Yeah, -2. -2. X.
And then add
Plus 1.
plus 1.
And then what?
Minus 0.5.
Is it translated by 3? Would it like be?
It's translated by 3. So that means this output is going up 3.
Multiplied by 3. Added by 3.
Yep, it's translated up 3, so we're adding 3. So we have this output plus 3.
That's what I meant when
Yeah,
I did like.
we're kind of going backwards. Before they were giving us the g of x, and then we had to say what's happening. Now they're saying what's happening. It's translating up by 3, and we just have to write it that this entire output, not the input, the entire output, 3 is being added
It
to
says
it.
that it's wrong.
Yeah, it said it was wrong.
It said this is wrong?
Yeah.
Okay, so maybe they want a simpler, they maybe want you to simplify it without the parentheses. So it might look like this. First of all, you didn't type g of x in here, did you?
No.
Okay, so what you're gonna write then is -2x plus 4. See if that works.
It does.
Plus 4.
Yeah, because 1 plus 3 is 4.
It's
That's right? Okay.
I got right. Ugh, there's no part.
There's 6.
Do you not read the top where this part is 6?
Whoops. Yeah.
The next part and then the next one after that have the same.
Oh, really? All right.
I can.
Now, it says, we have our function rule. It says the domain of g, which
Is or is not.
is or is not identical to the domain of f. What does domain mean?
That's the
What?
Output.
The input or our
X.
x values, right? No, domain is input.
Oh.
Domain is your x values. So our domain, we want to know how these compare. And you can even click on the graph. This says the domain x is all real numbers. Let me just click on the graph real quick. Okay, so there's our first function. And then our g of x, remember, is -2x plus 4. exact same slope, different y-intercept. So positive 4 would be here, and then it would have the same slope, which is down to over 1, down to over 1, down to over 1. So, now let's compare the domain. The domain of this is all real numbers because it's going to continue on and on forever to negative x infinity. It's going to continue on and on forever. Even though it's going down, 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 it's still going out, out, out to positive infinity on the x. What is this one doing? What is our new one doing? In terms of the domain.
Going up. Oh, down. No, it's negative. What? Whoa, what is
Let's
it?
talk about the first one. It tells us in the table that the domain for this first line that they graphed is all real numbers, meaning all x values will be on this line. Every point on this line will have a negative x value. Every point on this line will have a positive x value. Even though it looks like it's getting further from the x-axis, it's still going outward to the right. Even if it's going down, it's still going to the right. It's going down and to the right continually. So it's going to go all the way to positive infinity on the x, all the way to negative infinity on the x, and include every single real number, even in between the integers, right? Do you get that about what they drew? Now what I drew is a parallel line to that. That also continues all the way and all the way. So what does that mean about the domains?
It's parallel.
That the lines are parallel. What does it mean about the domains? Meaning the x
They have the
values.
same.
Same. Very good. So they are,
Is identical?
so it is identical.
Yay.
Compared to the domain of f, the domain of g is, okay, well if it's identical, is the domain broader, meaning has more numbers, narrower, has fewer numbers, or neither narrower nor broader has the exact same numbers?
Ouch.
Neither, because it's the exact same numbers. The domain of G is neither narrower nor broader, has the same minimum. The minimum is negative infinity. And has the same maximum. So even though that has a lot of parts, it's actually super easy, right? Because once you identify that the domain is identical, then everything is, well, it's the same, it's the same, it's the same. There's another part. The range. It's okay, guys. I've got good news. The range of the first one says y is a real number. It's all real numbers. Look at our graph. So guess what that means about guess what that means about our graph here?
It's the same.
It's exactly the same.
Oh my gosh.
Okay? Because this is going to be going all the way up on the y and all the way down on the y, and ours is going to be all the way up on the y and all the way down on the y. So all the answers are going to be exactly the same as this. It is identical. Do you guys totally understand that?
Yeah.
The range is neither narrower nor broader. It has the same minimum and has the same maximum, which is infinity in both directions.
Just like that.
Is that it? No!
There's 6.
Compare, I was hoping like all those fill-ins were part of the 6. Compare the slope of G to the slope of F.
I don't know.
You don't know?
Let's go with a fraction.
Totally.
Compare the slopes
Totally.
of those two lines that we just drew.
Totally not.
That's what I said.
It's not the fraction one.
I mean, if there's
It's
a
wrong.
fraction, it's always a fraction.
Compare the slopes.
B.
Why?
Because it's comparing the slopes.
But how are,
The slope of B is equal to the slope of X.
you mean the slope of F is equal to the slope of G? He's right.
Equal to the slope of that.
Yes, because they're parallel lines, you guys. It was only the y. Look, here is the original. Look up here. Here's the original. This is the G. This is the f of x. This is g of x. The slopes are the same. It says it right there. They're parallel lines. So the slope of G is equal to the slope of F. You guys got it? Is that it or? No, my gosh.
Yeah, but one.
Is this one more?
No, two more.
Oh my gosh. Compare the y-intercept of G to the y-intercept of F. Well, you tell me. Compare the y-intercept of G to the y-intercept of F.
3.
It's 3.
B.
It's 3 more. The y-intercept of G
No, wait, 3.
is greater than the y-intercept of F. It is
No.
3 units greater.
The x-intercept.
Wait, what?
Nope, never mind.
Compare the x-intercept of G to the x-intercept of F. Okay, no big deal. Let's take a look. The x-intercept of F is 0.5. Let's get the x-intercept of our new one. I'm going to go ahead and write it as a linear equation rather than a function. I'm just going to say y equals negative 2x plus 4. How do we find the x-intercept?
You
Replace
the y
with?
with another y.
With another
With
brother.
with it's like I remember how we used to do it.
If we're looking for where the line is going to cut through the x-axis somewhere, then what is the value of y? Anywhere it's going to cut through the x-axis, what is the value of y? Look at y. Look at all the values of y. Here are all the positive values, here are the negative values.
Negative.
Anywhere it cuts through this x-axis, what is the value of y?
X.
Anywhere along, okay, what's the y value at this point? What's the y value of this point
It's
right here?
positive.
What's the x value of this point?
1.
What's the y value?
1.
0. Thank you. Running out of Jolly Ranchers. I'm going faster.
Okay.
What's the x value of this point?
0.
The x value.
Oh,
Plus 2.
What's the y value? 0. What's the x value of this point?
Plus
What's the y value? So anytime you have a point on the x-axis or a point that intercepts the x-axis, your y value has to be
0.
0. So go ahead and plug in a 0 for your y or your output and solve for x. So we can subtract 4 from both sides. We get negative 4 equals negative 2x. Divide by negative 2, divide by negative 2, and you get 2 equals x. So let's compare them. The original function says the x-intercept is 0.5. The new function says the x-intercept is 2. So let's take a look at our options. The x-intercept of G, is it greater or less than? It's greater. By 1.5. Very good. That was a tricky question.
I got it, Brandon. Wait, what's the next part? I'm so confused.
There's another part to this?
No.
Okay.
Oh.
That was just the x-intercept question. One more, we can do this. One more.
6 parts again. Let's go.
But it's the same thing. So we're just practicing it
But
again.
it's way easier.
It's easier? Yay!
This is not my one.
Oh wait. Oh shoot.
No, it's not.
It's a scale factor of 4. We haven't done that yet.
I got that.
Do you want to try it?
I got that. I got
No,
this
but
question
sure.
from the final.
You did the whole thing? All right, Ricky, help me, okay? It's a vertical stretch of the graph by a scale factor of 4. So a vertical stretch means a vertical stretch, I'm referring to my book because I don't have these memorized, is a vertical stretch, a scale factor of 4, which means the entire output is being multiplied by 4. So if we have function of g of x would be multiplying the entire output by 4. So it'd be 4 times negative 2x plus 1. And again, we did not do an example like this yesterday, so I'm kind of teaching it now. Okay. 4 times negative 2x plus 1. The entire output is being multiplied times 4.
You should have right.
Well, if you're going to write that in here, you're going to want to distribute. Why? Did you write that in and it got it wrong? Okay, did you distribute?
Well, now.
Okay, so we're going to distribute, and so that will be negative 8x plus 4.
Oh, so now we can distribute.
Yeah, we can distribute because it's funny because when they give it to you, they don't distribute because they want you to see what's happening, but when they want you to simplify when you're actually writing it, so this would be negative 8x plus 4.
Miss Lloyd, this was the easiest question.
Well, you are just my little genius, aren't you?
Well, the two next questions, like for this part, are the same as the last ones. Like the answers are entirely the same.
Okay,
I remember this being.
well, let's take a look. So now we are comparing this function with this function. And it says the domain of G, is it exactly the same or is it totally different?
No same.
They are the same. Let's look at the graph. Because if we were to graph negative 8x plus 4, we would graph our positive 4 here, and our negative 8 would be down 8 over 1. 1, 2, 3, 4, 5, 6, 7, 8, and then over 1. So we would have our little vertical stretch here. Sorry, I'm not going through my points very well. But the domain is still going to be exactly the same. They're both going to negative infinity on the x and positive infinity on the x. And what's that going to mean for our y also? What about the range? Is the range going to be identical or no? Yeah. So it's going to be neither. Has the same. Has the same. Answer. Good job. The range is identical. Are you guys totally following this?
Yeah.
Has the same and has the same. That's a beautiful thing about a diagonal line. It's just going to be diagonal line that continues in both directions is just real numbers for the domain and the range. Okay, compare the slope of G to the slope of F. So we have, where did our things go? Okay, they're up here. The slopes goes from negative 2 to negative 8. Let's see our answer choices. So we're going from negative 2 to negative 8. What happened? It is a what?
B, the scale factor.
It is scaled by a factor of 4, meaning it is multiplied times 4 to get 8. Negative 2 is multiplied times 4 to get 8, just like it told us originally. Are we good on that?
What was it?
You have the same numbers, right?
Yeah.
So it's the slope of G, because we're going from a slope that's negative 2 to negative 8. So I know you want to be like, oh, you just subtract 6. But it wasn't subtraction because we had to multiply the whole thing times 4. So it was scaled by a factor of 4. Scaled just means it was changed, either increased or decreased by multiplication of either a whole number or a fraction. In this case, it was a whole number. Zach, can you see me on the camera, or am I totally off camera right now?
You're half over a little bit, like half of your body's in it, and then half your body's not in it.
Okay. Well, I guess they can see this though, so that's good. Okay, compare the y-intercept of G to the y-intercept of F. Let's just compare them.
If you
1
if you want,
and
I can move
4.
it back.
What?
I can move the camera back so it sees more.
It's okay, I'm almost done. So, it went from 1 to 4. The y-intercept went from 1 to 4. The y-intercept of G, is it less or greater? Greater, because it went from 1 to 4, and it is how many units greater? 3. Technically, it was a scale factor of 4, but
And the next one, you already made it go up 4.
I don't. Compare the x-intercept of G to the x-intercept of F. I do have to go up. The x-intercept of F is 0.5, right?
Yeah.
Okay. So the x-intercept of x of the f of x is 0.5. Now we need the x-intercept of g of x, which what was it? Negative 8x. Okay. Negative 8x plus 4, right?
Yeah.
Okay, so we're gonna set our function of x or our output or our y equal to 0. So we have to subtract 4, we get negative 4 equals negative 8x, cancel, divide by negative 8, divide by negative 8, and we get negative 4 divided by negative
1
8.
over 2.
Yeah, it's 1/2. The negatives cancel out, and we have 4 over 8, which is 1.
Is it
greater
half.
than less?
It's C, it's the same because 0.5 is the same as 1/2.
Very good, it's exactly the same. The x-intercept is exactly the same.
Good.
Very good, Callie. Sorry, no, I'm just kidding.
I want to draw your answer and finish my homework.
Good job.
Good job for you, Zach. We all.
All right, did you guys totally understand?